Dr. Nitin is a PhD in chemistry with 29 years of research experience in environmental and energy-related research. Okay, and he works several places, in fact, as a visiting overseas, and a lot of papers, 130 research papers he published, with altogether 280, 28, you can say 100 citations, and he has 22 international patents. It's enormous, and I can see a lot of patents that he has. May I request Dr. Nitin that you can please deliver your talk.
Good afternoon, and thanks for the kind words. As he has instructed, we have to keep in time, and when Professor Avinash asked me, I was not aware that it's a locomotive-centric sort of theme. So I tried to add on a couple of our experiences. I come from National Environmental Engineering Research Institute, which deals with the environmental engineering and management, I would say. And these are the quite a few areas which we deal with. And most of the projects are related to industrial exhaust and then vehicular emission control and management, I would say. Then we have some of the societal mission projects and now health-based project, because NEERI has quite a strong team related to biotechnology, I would say. And then we have a program called CSR 800, where we do some work related to societal mission. As far as renewable energy is concerned, we are a part of a solar mission project of the Government of India and TAPCOL project, and a colleague of mine also works with the hydrogen storage. And we have a website, so you can please check the website for the further details. As I said, that we come from the Environmental Engineering or Management Research Institute, so we look into that perspective that three issues as far as environment is concerned. One is the air pollution problem, which probably we talk too much about. Then comes the global warming, the CO2 emissions, and other environmental impact. Nowadays, like for example, we have a concept of life cycle assessment. So each and everything which is a part of the automobile or related components should form this waste disposal. And as you know, the traffic accident is also a big issue. So these are the overall relationship when we talk about the automobile. Well, this is I'm just showing because many of you will show it and already shown it, in fact. If you see the tightening of emission norms, it's hitting bottom. There's hardly any scope left for, I would say, the new vehicles. And this I'm intentionally showing because even after tightening of so much of emission norms, if you see the scenario of pollution in this in our country, this is part of the CPCB 2011 report, okay, which NEERI along with many other organizations were part of it. And the first graph shows the Bangalore and the second is the Delhi. And that line is the emission, like the PM levels, RSPM level. So in most of the cities, we are exceeding the limit. So despite the fact that we have tightened the emission norms so badly, the present scenario is the PM levels are going up above the standards. And if you see the source apportionment result of that particular study, which is now 5 years old, I would say, and new data is coming, like I'm sure my friend Tarun will show some of the data. The source apportionment study really confirmed that in addition to the road dust, which is one of the significant part of the PM emissions in India, the diesel emissions are also significantly contributing. So two things are sure, that diesel emissions are increasing and the contribution of vehicles are also significant. If you narrow down that what kind of a vehicle, then this particular study suggests that around 50% of the PM emissions are coming from heavy duty diesel vehicle, okay? But that is a pretty city specific trend, okay? So heavy duty diesel vehicle contributes, but then we have a city specific. For example, in Bangalore, probably it is significant. I would just go one step further, that what we are talking here, based on this study or all previous study, and this I try to project wherever I find opportunity, that we are talking in terms of the mass of the particulate matter. But can we really compare the 1 ton of road dust particle and 1 ton of diesel PM at NEERI and at many other environmental engineering institutes? Nowadays we talk about the not emission based target, but the health based targets, okay? So if you see the projection, and when you go to anybody like a minister or bureaucrats, they say the major issue is the road dust, okay, because the road dust contribution is pretty high. But can you really compare the 1 ton of road dust with the health impact of 1 ton of the diesel particulate emission? So it's high time that we should start projecting the overall health impact of diesel emissions. Sometimes its contribution in terms of the mass or weight basis, maybe 10%, okay, but the health issue could take, in fact, the diesel emissions quite up. And there are beautiful posters I can see where we can show, we have seen this one. Oh, sorry. And where's the pointer? This one? Oh, this I'll use only this. Thank you so much. So this is one thing which led us to believe that in many cities the contribution of diesel particulates in terms of the mass emissions are less, but if you see the health impacts, it will be much severe. So what is our first job as far as emissions, locomotive emissions in this country is concerned? To estimate emissions and impacts from locomotives. And Professor Avinash Agarwal, I remember, has made a beautiful presentation during last ECT that they are already on the job, okay? This is very much required in environmental management point of view, because we are still a developing country or less developed country where every rupee counts to us, and we cannot project one issue and hype about that issue, because we have more burning problems related to food and poverty and health issues. So with over 5,000 diesel locomotives, probably this number is less, it's about 6,000 plus, an addition of another 300 every year. The fuel consumption is enormous, 2.6 billion per year, okay? And these are the this I had taken raw, roughly 50 kilotons PM, and nowadays it is possible to estimate the social cost or the impacts, okay? Let us see what are the strategies for vehicular emission control, because this is quite similar, I would say, and we should learn lessons from the vehicular emission control program, which has completed almost 20 years in this country. So engine technology, I'm sure there were many good deliberations. Revision of emission norms, introduction of emission norms are rather on cards. Adoption of vehicle pollution control technology, this is how we go. And I have intentionally made it red because proper implementation has been a problem, and today even a problem. But when it comes to the locomotive, we can have a better control. As far as I&M is concerned, this country is probably suffering most because of the lack of inspection and maintenance. We can have better control when it comes to the locomotive. Traffic planning and management is another issue, and majority of the emissions in the metro cities, or for that matter even in Lucknow, comes from this. This is probably no issue when it comes to the locomotive. Improved fuel quality, so I was told that they are using the commercial diesel, which is of decent quality now. Inspection and maintenance of emission control equipment, again we can have a better control, because if I ask you that what happened to the first catalytic converter fitted on the Indian car, nobody knows. It is still there, it is maybe completely blocked, because the converter we have removed in Nagpur, I found more than 50% of the converter should contribute more to the emissions, because we found and partially damaged even the ceramic support. So this is the state. Now I'll briefly introduce, because we have got an expert from Sood Chemi, and briefly this was discussed. This is the scenario of diesel emissions and what are the technological options. I'll restrict to the after exhaust treatment, because engine is neither my area and it has been already discussed very much. This is how the diesel particulate forms, and during its cooling process, two things happens, one good and one bad. The better part is it gets agglomerated and the size increases so that its penetration or inhalation is restricted. But the bad part is most of the hydrocarbon starts getting absorbed on that, which actually offers the carcinogenicity or the more harmful health impacts. Three options are quite popular as far as vehicles are concerned. The very first is a diesel oxidation catalyst, where we tread with what is known as the soluble organic fraction. It's quite similar to the petrol-based catalytic converter, and we can expect oxidation of hydrocarbons which are associated with the soot particles or with the PM, in fact particulate matter. And sometimes it is possible the exothermic heat generated out of this oxidation may also contribute to some extent about oxidation of carbon. And this device is quite simple, where this is the typical particulate matter. Here you have coated the catalyst, and what we are losing is a soluble organic fraction. If you have more fraction, then the efficiency is more. But typically, it gives 20 to 30% of efficiency, a moderate efficiency, but it's relatively requires less maintenance. So most of the vehicles probably, he would be able to tell us, but in India, they are using the DOCs and not the DPF. The second device, which is most efficient, is diesel particulate filter. And now they say for Euro 5, we may need DPF. So for filtering the particles, obviously a filter is the most efficient device. So the commercial filters are available with very high efficiency. But the issue is, after it gets clogged with the soot, how to regenerate it, okay? Because it burns at about 550 to 650 degrees Celsius, while the diesel being a lean burn engine, the exhaust temperature is quite low. So regeneration of DPF or diesel particulate is the major challenge, and there are two major sort of approaches. One is the active regeneration with fuel injection. This may be a possibility with the locomotive also, because it's a huge engine in fact, and there's some scope for this, but certainly there will be a fuel penalty which we should be taking care. Then second is a catalyst assisted or CRT. This is from Johnson Matthey, where I think in the last session this discussion was already held, that there is a DOC. The job is to oxidize NO into NO2, and this NO2 then reacts with the trap particles to regenerate it. And these are most commonly used for the vehicles. In between comes the partial flow filters, because DOC doesn't have a back pressure generally, and the DPF has a high back pressure. So this compensates for these two, and of really good development during last 1 decades, and a moderate to high efficiency we can achieve. So 3 devices, 3 different kinds of efficiency, 3 different kinds of maintenance. So this partial filter technology, again, I have taken from the Johnson Matthey. So this is the background, that we have diesel emissions. Diesel emissions from vehicles are significant. Then we have got certain estimates about what kind of emissions are there from the locomotives. And there are 3 options which we tried on the vehicles. I certainly don't have any experience on locomotive. What are the R&D opportunities? Where do we stand, or where do we work? This is a typical reaction for soot oxidation. The NOx plus carbon has a favorable delta G, what we call in chemistry or thermodynamics, and this reaction can happen at as low as 200 or 250 degrees Celsius, although 300 or 350 is more desired. But the dependency on NOx is one issue, and second thing, most of these reactions are catalyzed by noble metals. Okay, so the first driving force: can we catalyze a reaction without NOx? Can we have a reaction soot plus oxygen and we can regenerate? And second driving force is, it's all noble metals. So this is the consumption. About 55% of platinum, again 55% of palladium, and 90% of rhodium are being consumed only in the environmental catalyst. Okay, so there is a good possibility to explore the non-noble metal based catalyst, but the application is very, very tough, I would say. We have been working for last more than 1 decade. So we have 2 approaches. One is to reduce the amount of noble metal, but again, people have already hit the limit, okay? And once you change the size of the particles, the chemistry itself changes. But one of my, I would say, postdoc wants to work on this. And second, the possibility of non-noble metal-based catalysts. The only driving force is now we are getting a cleaner fuel, okay? So the stability is not so good, but with the sort of introduction of the ultra-low sulfur diesel and all. This is how we are working. That, this is the noble metal based catalyst particle. We call it a dead volume, although the particle size is small. So can we remove this dead volume and make a hollow structure so that you can save a lot of noble metals, okay? Then you have to worry about the stability of such kind of delicate structure. So we are starting with the milder application like VOCs and other applications, not really auto exhaust. But this is one of the approach where we are working, okay? Second approach is we are exploring quite a few catalysts which contains, which either doesn't contain or contains a very, very small amount of noble metal. So the entire emphasis to reduce the cost of the materials, okay? I'm not going to go into the details for 2 reasons. It's not a chemistry-based audience, and second thing, for time constraint. But this is one class of compounds we have been exploring along with a couple of our collaborators, where we do exploit the knowledge of chemistry to design different catalysts. These are some of the catalyst compositions we recently explored and found interesting for diesel soot oxidation. Now, when it comes to the laboratory-based catalyst evolution system, if somebody is interested, then we use 2 kinds of system. One is a thermogravimetric measurement, where you can put the soot and it gasifies and you get the weight loss. Next time you mix the soot with the catalyst and check the temperature. But probably the more realistic evaluations you can do by this kind of setup, where you can create a automobile exhaust or any exhaust of simulated composition, and then you have a reactor where you can manipulate the temperature, and a gas chromatograph and NOx analyzer will give a fairly good control what is happening at what temperature. So we like this kind of assembly very much, and this is the kind of data we get. For example, if you burn the soot, it will give you a CO2 at this temperature. With catalyst, this should reduce, but you can see this is the bare soot, and it also varies a lot. I mean, these are the report from academic world, that depending on the soot composition. After catalyst intervention, you can get a peak at around 350 or 400 degrees Celsius instead of say 600 degrees Celsius. That gives us some idea about the catalytic activity. So normally the academic world uses these kind of things, and then the next job for us is to go for the full scale prototype, which is fairly complicated. So I collaborate with the Japanese university, where they have a bench scale facility where you can have a 200 cc of prototype, and they kept a diesel engine here, and you can have an exhaust flow, and you have a much better control over the things as compared to the prototype. This is the result, quite similar to that. Without catalyst about 650, and with catalyst it starts about 400 degrees Celsius. The last stage, I would say, for R&D is the evaluation of prototype. And here we collaborate extensively with Professor Avinash Agrawal and Professor Tarun Gupta at IIT Kanpur. It's amazing facilities they have. So recently our students prepared some prototype using purely non-noble metal-based compound. This was like DOC, and then we did a canning for sort of prototype testing at Professor Avinash lab. You must have visited on Sunday. This is the engine we have used. This is the setup, so I'm not going to spend much time. This is the data. So there were two interests. My interest was to evaluate the catalyst, while Professor Avinash's interest was to use the B20 or the biodiesel blend. And we found that the diesel with the DOC and B20 with DOC, as far as CO emissions are concerned and THC emissions are concerned, there was significant reduction. And the temperature was also fairly acceptable, 200 degrees Celsius for CO, okay, in both the cases. So CO and SC, we got decent data, and some reduction in the particles also. Okay, particle number side, they have good facility. So this is the particle number side distribution with the different load conditions. So I would say DOC is anyway not expected to give you a very high efficiency. So in this particular case, we could get, in some cases, 20 to 30% of reduction in the PM as well. Okay, so there are quite a few data, but again, I would say I have to. This in particularly I'm showing because as far as I see, the 6,000 locomotive engines, and we are adding just 300 every year, which are supposed to be cleaner than the engine what we already have, or in-use engine. So the majority of emission, if you see, will come from these old or dirty engines. Okay, so we need to really seriously think about that, and I think a few studies worldwide shows that retrofitment could be an option. We have done some retrofitment studies with respect to the city buses, the old city buses, and probably that could be useful. I'm not very sure. Okay, so as far as city buses is concerned, they are also one of the main targets because the city bus roams around inside the city, and its impact is more than the intercity buses. So there was a US EPA sponsored project in Pune where we attempted this, and 3 devices to be attempted, like DPF, DOC, and partial flow filter, what I have shown you. And this was a typical bus. Okay, we selected 20 buses, and to some extent we were forced to try DPF while there was no experience whatsoever even on the new buses that time. This was our metric. Fortunately, quite a few institutions were involved. Our technical partner was Johnson Matthey and Southwest Research Institute of USA. PMPML is the bus agency, in fact, and ARI was responsible for other things like testing and all. One issue we faced the time that you fix a device and something happens while the bus is running, then there is a big public unrest. Okay, so you need to take care of those things. So what we have done, we have put a sort of CRTDM sensor. It gives signal to the driver, and then we made a kind of a, like bypass. There's something, if the bus stops, what to do? Okay, we have to adjust the 50, I'm sorry, maybe 100 passengers in a bus. So you can bypass automatically. So these kind of preventions you have to take, and before that goes an enormous amount of preparation. To start with the cleaning of fuel tank and, like the maintenance of buses, and to tell you, the fuel tank was containing not less than 80 or 100 kg of sludge. Okay, that was the kind of sludge we found in the fuel tank. So please be careful before you start blaming to the technology provider like Johnson Matthey that your device is not working. There could be tens or maybe hundreds of other reasons. It's a tough job we found. And then the kind of buses were given to us were maintained, I would say, in terms of fuel efficiency, because that is the interest of all the corporation. But in terms of emissions and all, it was hard. We used to take a periodic emissions, okay, and one very interesting exercise we did with SWRI to kind of get an experience of on-road experience. There have been a lot of good or bad news we must have heard during last couple of months, in fact, from very leading automobile manufacturers about the cycle beating and other things, okay? And people are calling it a huge scams. And we had some experience that we were not getting that. SWRI helped us that let's do some onboard trial. And for that, what we did, we hired two like Ducati PM analyzer, and we fixed one analyzer before the device and after the device. And we did a lot of complicated preparation. So you have a bus, and inside the bus you can mount all the equipments. You can put some sandbags to simulate the passenger, to simulate the passengers, and then you can take the emissions right from before the DPF and after the PPF, and you run the bus, okay, as the bus goes. And we followed one typical pattern of a city bus, typical speed and everything, and that gave us some kind of interesting data with respect to the exhaust temperature, with respect to the emissions, and what are other problems you might be able to face. The efficiency was ranging in a very, very wide range, I would say, sometimes plus 60 or plus 70 to even minus, I would say, 20, okay, which could be because of the blow-by, that some emissions were trapped and then there was a blow-by, okay. Exhaust temperature in general we found was quite low, very, very low. That was the major challenge, in fact, because the city bus can hardly pick up any speed. But I don't see that problem in the locomotive. So there's going to be some advantages. This is the data from ARI, okay. This is the baseline and then the DOC and the new DOC. Again, I would say the data was very much varying. This data cannot be statistically justifiable because we have tested only hardly 6 or 7 buses, okay. So we gained experience, I would say. It's not possible to test multiple buses for cost reason and other reasons. This is another set of data on partial flow filter. But what is interesting to show you, these are the pictures we used to get when we remove the devices, okay. It's completely laden with the soot, and sometimes the filter got damaged, and when we talk to the Amitech people and JM, they say the temperature must be around 11 or 1200 degrees Celsius. So these kind of modes to be prevented, and then there was a possibility we used to just clean it aerodynamically because it was a pilot study, and we found it, we can clean it, but we do not know whether it will be practically possible at larger size. So these are some of the lessons learned, but please, these are all restricted to the vehicles and in particular the city buses, okay. So I would move to my final slides, that this is the experience we have, but if you compare this experience with the locomotives, what I understand that there could be some advantages, that they are limited in number, like we call it 7,000, while Delhi has more than 9 million vehicles, okay. So 7,000, controlling 7,000 is not a big deal. Better inspection and maintenance because technical support is well in place. Engine vibration I am not aware, but the track related vibrations are not much, okay, as compared to the buses. Something between mobile and stationary sources. Whenever some problem comes to us, we love the stationary sources, and we don't like the mobile sources because there are plenty in number, there is no control, and that's why I personally feel that diesel genset is a better option than the diesel vehicle because there are hundreds of issues. User intervention is minimum, skilled user. In Nagpur, I don't want to name the company, but a two-wheeler, very recognized multinational companies. When you send your two-wheelers for what you call regular checkup or servicing, they offer you some kind of a cleaning or some putting some liquid on catalytic converter, okay. And without knowing this background, they were forcing me to go for that thing. So I don't know, but in this particular case, probably we'll have a better control, better fuel quality control, and we have a lot of experience. I put question marks on excellent because initially we have learned quite a few things, which mistakes I would consider, and we should not repeat those. And there is already a willingness. What could be the challenges with respect to the locomotives? That engine out emissions and emission characteristics need to be known, and RDSO is working hard with Professor Avinash lab, in fact. Soot NOx ratio, the exhaust temperature, exhaust volume, which I am sure will soon listen from an expert. Space constraint, I can imagine. Limited experience worldwide. SWRI has some experience we discussed. No compromise on fuel penalty or fuel handling, especially when you talk about the DPF regeneration, there's often a penalty. Adoption and implementation cost. and preparedness for the failure mode, as I told you, but this is all can be taken care. And this is the first introduction, and I am in training. So there are plus and minuses, but I would say that if you go by the overall scenario, the diesel PM emission is one of the major challenges in this country. Okay, so we have to start from there, that we need to do something with the diesel emissions. Locomotive can have significant contribution and also an attractive option for emission control. As I mentioned, nowadays people don't talk about the emissions, let it be water or exhaust. They talk about the health-based targets. You can reduce the emissions, but are you getting some benefits out of it? Okay, so let's talk health-based. There is a water reservoir which contains fluoride, but nobody is using. We should not touch it. There's no need to invest money on that. So we can have health-based targets. So locomotive can be this significant contributor. Engine volume capacity comes roughly 1 million liters. I was just comparing with the vehicles, and not really very high. But pilot project will be essential before widespread application, and there's a good possibility of pilot project, I would say. And again, I would say multi-institutional efforts will deliver better outcomes, and we need to have involvement of all the stakeholders in this particular case, taking advantage of a lot of experience. So thank you so much, and I would be very much grateful to Professor Avinash Agrawal and ISCES, and most of the work is done by my student and collaborators. Thank you so much for the patience hearing.
Thank you very much from my side also.
Yes, sir.
I had one question, like you showed that hollow noble metals. So what is the typical size of that sphere, the hollow sphere?
Yeah, that's a real challenge. So we're starting with the attempting, I would say, 100 nanometer, and we have to go down to say 50 and 30. So 100 nanometer was possible, okay, and you need to take some, template, the proper template which can give you, the challenge is the template which is usually a polymer. So the first thing is your polymer should be of that size, and it should have some functional group so that you can attach a noble metal and give a treatment so that the noble metal get attached and form it, and then burn it.
Is it similar to nanofiber, different?
Nanofibers are generally, they are also good. I mean, the dead catalyst volume is quite low, but we are talking about the sphericals where dead volume is significant.
Thank you very much.
Thank you so much.